Okay, so in this video, we're going to be looking at sketching gradient functions. And what a gradient function is basically a graph which shows how the gradient changes in a function. And so in the gradient function, what you have on the y-axis, or on the x-axis you have x, but on the y-axis you have f prime of x. Because this is used to show how the gradient will change. There could be like an increasing gradient part, a decreasing, there could be a stationary point, and this just shows what the gradient does as x increases. And here's a table of how it would relate to the function. So if we have a maximum or minimum point, that's when the gradient is 0. It's a stationary point, right? So this is when in the gradient function graph, it will cross the x-axis, because the x-axis is when f prime of x is 0, i.e. a stationary point. A point of inflection, once again, is when it's a second derivative is equal to 0, right? So that's when it touches the x-axis. It's not going to cross it, it's going to touch it. Positive gradient is going to be above the x-axis, because that's when f prime of x, the increasing function, is going to be a positive value, right? Negative gradient means it's a decreasing function, so the graph is going to be below the x-axis. If it's a vertical asymptote, then that's going to be the same for the gradient function. And a horizontal asymptote is when it's going to be equal to the x-axis. Now, this table is quite useful to use and remember, but I just recommend you guys just understanding the whole concept of it, and then you don't have to refer to the table. You can just look at the function of the graph and then just do it by intuition and just by your knowledge. Okay, this table is a good hint for you guys, but I don't want you guys to rely on too much. Let's try this one here. So we have a function like this. I'm going to draw a graph underneath it. We have f prime of x here, and we have x here. Okay, so let's split up into certain quadrants. So let's say we go up to here first. Okay, so as you can see in this graph, the gradient is increasing, right? It's a positive gradient, okay? So that means it's going to lie within this section here, because it's a positive gradient, right? But then you have to think, so first of all, it's increasing, and now you think, is the gradient getting bigger or smaller? I.e., is it getting steeper or less steep? So in this case, you can see that it's going to get less steep, right? Because it's reaching a stationary point at this minus 9. So at minus 9, it's going to be a stationary point, meaning the gradient is 0. So that means, in fact, the graph will look something like this. It's going to come down at minus 9. It's going to touch the x-axis. That's when the gradient is equal to 0. Next part is, let's go from here. You can see from here to the origin, it's now going downwards, meaning it's a decreasing function, meaning the gradient is a negative value. So it's going to lie in between here. Okay, and then you understand that it's going to go down, and then it's at the 0 point. This is also a stationary point here. So this graph will look something like this. I'll just get rid of this one. It will look something like this, and then at the 0 point, it's going to have to come back up to this point here, because that's when the gradient is 0. Let's look at this portion here. So as you can see, same thing. The gradient is increasing. It's an increasing function, so it's going to be above the x-axis. And at this point here, it's going to be a stationary point, right? So it's going to have to go up and then come back down by the time it's at 6. Because it has to be a 0. And then as you can see here, the last part is a decreasing function, so therefore it's going to keep decreasing like this. So you can see this is a gradient function graph for this graph up here. And as you can see, if you split up into equal segments or just important points, i.e. stationary points, and just imagine to yourself, there's two things. Is the gradient increasing or decreasing? And is it getting steeper or less steep? That way you know which way it's going to go. Let's try this one here. So I'm going to draw the graph underneath. First things first, you should notice there's a vertical asymptote, and for all vertical asymptotes, they are the same for the gradient function. So I'm going to draw this one here. X is negative 7. Alright, so let's start off with this section here. So as you can see, the gradient, the line is going downwards, meaning it's a negative gradient, right? And first, that means it's going to lie below the x-axis. And then how steep is it? Well, it's quite shallow here, but it's getting steeper, 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 right? So the gradient value is going to increase negatively. Okay, so it's going to start here, and it's going to get steeper, 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 like this. Next part, let's go up to here. So this section to here, as you can see, it's also decreasing, so it's a negative gradient, but it's getting less steep as you decrease, right? And it's getting until point 4 here, where it's a stationary point. So let's mark the point here 4. So it's a negative graph, but it's getting less steep, so closer to 0 essentially. So it's going to go from here, and it's going to go less steep like this, until it reaches 4, where it's a stationary point. Past this point here, it's briefly a stationary point, but then it keeps decreasing like this, right? So it's going to be a negative part underneath the graph. and the steepness is increasing as we go along, so it's getting more steep. So therefore, from here, it's going to go down, and it's going to keep going down to be more steep. Like there's a higher gradient. So actually, it's quite simple as long as you understand what's actually going on with what you're trying to plot on this gradient function graph. Okay, let's try one last one. So first of all, drawing the axes. We have a horizontal asymptote in this case, right? And any horizontal asymptote is going to create an asymptote on the line on the x-axis, okay? So this is the asymptote here. Now let's split up again. So let's split up into here first, so -2. That's the stationary point. So this graph from here is decreasing, meaning it's going to be below the graph, and the steepness is getting less steep until 0. So it's going to decrease, and it's getting less steep until 0. Past this point here, it's going to keep going up. Now it's increasing. It's a positive gradient. So it's going to increase until, once again, it's a stationary point. So it's going to increase, and then it's going to come back down, right? Because it has to reach a stationary point. Last section here is now it's decreasing, but you can see that it is leveling out. It's getting less steep, right? So initially it was steep, but it's getting less steep as we go along. And so it's going to be steep in the beginning, but it's getting less steep. It's going to get closer to 0, the gradient. So it's going to come back up like this and go along the asymptote like that. So this will be the gradient function for this one. So as I said, yes, the table is very useful for us. It's good to memorize parts of it or all of it, but I don't want you guys to rely on it. I want you guys to visually think about yourself, what is happening to a gradient in each section. So split it up into stationary points and then look at each section between each stationary point and imagine to yourself, is it negative, positive, and is it getting steeper or less steep?